Now, I'll try to not make it too long. I'll try to squeeze in as much as I can. Now, the reason why we're doing today's seminar is it's going to be a series of webinars. Every once in a while we do these because there are lots of hidden things which people don't use or are not aware of, and they sometimes miss them. And these are to do with certain macros and certain files which are used by macros. So the purpose of this webinar is to basically introduce you to those kind of hidden features which people don't end up using sometimes, and basically let you know that they exist so that you can benefit from them. Now, in COMOSYS, we have a technology which we call one-click connect. A one-click connect basically means that when you're using a macro, you just basically select the macro and you go click, click, and it's supposed to give you a connection which is acceptable for you. Now, normally in any connection, there are many things you need to enter, and these include things like plate thicknesses, weld sizes, bolt diameters, the distances between bolts, what we call the interbolt distances, then things like gauge distances for angles or flanges. Flanges have their own gauge lengths, gauge lines. These are all things which need to be entered when you're using a connection, and these are very time-consuming things. So we have developed this technology called one-click connect, in which you have this intelligence built into the system, which works in the background. And we normally, if you've set it up correctly, we expect you to just go click, click, and just select the main, select the secondary, and the connection is made. But of course, for this, you need to be aware of this feature, and you need to be aware of how to use it, how to set it up, how to customize it. And we will be talking a bit about that. And the first thing I want to talk about is angle gauge distances. Now, as you know, so for example, this is an angle, and it's going to connect to the beam. I'm going to use the bolted gusset connection. So I just select this one, and I right click, and I get my connection. Now, if I were to look at it from the top like that, as you can see, the bolts are there on the screen. Now, these bolts have been placed along a certain gauge line on the angle. Now, what is a gauge line for angles? These are, if you know your detailing, all standards recommend certain gauge lines for angles. These could be for single bolts, or they could also be for double bolts sometimes if you have enough space over there. And it's usually quite a mess because you need to remember these numbers and you need to enter these. You need to look them up from catalogs, and then you need to enter them inside your macros. For example, in this particular case, this is an angle which is 60 by 60 millimeters, and the standard says that the gauge distance should be 35 millimeters from the back of the angle, this gauge distance over here. Now, in COMOSYS, we have something called the angle gauge distances file. You can access this if you go to your preferences folder from here. If I click on that, and if I open the company folder, I can go scroll up, and you will see something called the angle gauge distances file. And if I double click on that, you can see that this file has this format in which these are the side lengths, these are the leg lengths. So leg length of 30, 40, 50, 60. What this means is between 50 and 60 would mean anything between 50 and 60. 65 would mean anything between 65 and the previous line. So 70, 80, 90, all the way to 200, for example. Now, this file is set up in a way that it gives the leg distance, and then it gives the gauge distance for that file, for that leg length. So for example, our case is 60. So it's telling me that the gauge length over here should be 35 millimeters. And these subsequent two zeros over here are telling me that I cannot insert two bolts, maximum two lines of bolts. So after, as you can see, if you come after 110, after 100, it says if you want to have one bolt, then the gauge line is at 60. But if you want to have two bolts, maybe they're staggered, then the first gauge line is at 40 and the second gauge line is at 70. And then you have the maximum diameter, which this particular leg length can. Obviously, you want to use higher diameters because you don't want too many bolts. So it kind of gives you a guideline recommendation in that as well. So because we see that for 60, it is 35, you can immediately tell from over here as well. For example, if I were to select this and select my, where is the work plane to object? Yeah, so it's on the object over here. So this is the Y direction. So if I were to now measure the distance from here to the bolt, you can see that it is 35 millimeters in the Y direction. I've set the bolt, the work plane in that direction so that we can measure really easily. If I were to then double click on this and change this to maybe 180 by 8, for example, immediately you will see that the COMOSYS has automatically calculated the new gauge length. Let me go in and measure from there to there, and it says 45 for the 80 by 8. And I just need to go and check my file for the 81. It is recommending a 45 gauge length. So this is very useful because what it does is it allows you to then not enter what we discussed in the beginning. That what we want you to do is not enter your bolt distances. So over here, otherwise I would have to come and enter these bolt distances, the gauge distances from here. But as you can see, I've left them blank. And this is what the whole idea of one-click connect is. That you don't enter anything in the macro. You don't enter the bolt diameter, you don't enter the gauge distances. We'll talk about inter-bolt distances as well in a bit. But the whole idea is to leave everything blank. And the blank one should work according to your needs most of the time. That's the idea of one-click connect. So as you can see, it's picking up this gauge distance from this file, and I've just explained the file to you. It's called the angle gauge distances file. You can come in and you can create your own angle gauge distances file. If you're using some other standards, you can modify this. And once you have this modified and saved in the preferences folder, immediately it will. So for example, if I were to use a higher, let's use this one, a 150 millimeter leg length. So I don't know what we have. Let's see. So if I use 150 by, or 150, do they have a 150 by? Okay, so let's this one. And if I do that, you see that it is immediately put two lines of bolts staggered. And for the 151, my distances were at 60 and 105 if I were to use two double bolts. And I can see immediately, if I measure the distance from there, the first one is at 60 and the second one is at 105. So I have no issues with entering these gauge distances now once I'm set up. Let's continue. Let me get back to my notes and see what we have. Okay. Now, another area where we use this kind of bolt distances is what we call flange bolting. So for example, in other places, for example, let's take this, consider this case, for example, we could have another connection. Let's say a haunch connection over here. Let's create a haunch connection between this one and this one. And this one over here, this column is HEA 300. Now, once again, the standard recommends that the bolts which are placed on the flanges of sections need to be at a certain line. And this line is well defined by the standards. It's not the typical gauge. These are also gauge lines, but different from angles. But they're different for every single section. And we don't want you to go inside the macro because that's time consuming. That's the whole idea. We don't want you to go inside the macro and then, basically enter some numbers over here because this is the part which is time consuming. We just want the macro to work directly. So once again, we have this file just like the angle gauge distances file, we have this file. If I go back to my preferences folder, I scroll down a bit. There's another file I want to introduce to you, which is called the flange bolting distances. Now, this one, if I double click on that and open it, this one has names of profiles, and then it has the maximum diameter of bolt which they can take, and then it has the gauge distance or the gauge line. And if you can have two of those, then it gives you once again like the angle one. So let me come back to my column over here. It's the HEA 300 section. So let's see what the file is telling me. The HEA 300. Let's go down. Yeah, it's over here. So it says it can take an M27 bolt. And if you're going to put one line of bolts, then it should be at 60 millimeters from the center of the section. So M27 bolts, 6 millimeters from the center. If I were to look at this from the plan view, let's go down like that. We can see that it has automatically used the recommended bolt size. I didn't need to enter that. And if I were to measure the distance from the center to the bolt, you can see that it is, I'm sorry, I need to first change the work plane again because my work plane was not located correctly. If I were to measure the distance from the center to the bolt, you can see it is 60 in the X direction. This is exactly the number which is given over here by the recommended gauge distance. If I were to, for example, do a smaller one, so let's use, for example, an HEA 200 section, which uses a 24 size bolt and 55 millimeters as the gauge distance, HE 200. And if I were to come in and change my column from HE 300 to HE 200, I get the modified connection. The bolt size is automatically changed according to that. And if I were to measure the distance once again from here to here, it is 55 millimeters, as you can see, in the X direction. This is very useful because what it's doing over here, it's saving me a lot of time. It's allowing me to do a one-click connect. It's choosing, now there are other things which of course might be coming to your mind. What about the plate thicknesses and what about this and what about that? We'll talk about those as well at some point. But the idea is that the inter-bolt distances, the bolt gauge lengths, etc., are very time consuming to remember. And if you see over here, automatically it's using the recommended bolt size, the recommended gauge distance. We can use another macro, for example. Let's go over here and let's use so what profile is this? This is the IPE 450. Let me use a flange plate moment connection on this one. This is a moment connection between beams and columns. And this is an IPE 450 profile. And once again, the bolts are located on the flange. So let me just check this IPE 450. What does it tell me? I need to go back. Let me go back to my file. It says that for the IPE sections, let me see where the IPE ones are. Yeah, there we are. IPE 450. This is the one, I think it's an M27 bolt at a distance of 53 millimeters from the center. So 27 bolt, 53 millimeters from the center. If I were to look at it from the plan view once again, like that, I can see that my bolts have been chosen accordingly. And if I were to, once again, measure the distance from here to here, you can see it's exactly 53 millimeters. So whenever there's a bolt on the flange of a member, instead of you digging up your catalogs and digging up your all the information and then entering it from there, the same obviously holds true for your splice connections as well. That's another place where, so let me find the splice connection. That's another place where you would have these flange bolts once again. So there'll be a flange and there'll be some bolts on the flange. All you need to do is set up your flange bolting distances file. And this will basically then allow you to ensure that one-click connect works perfectly. Now, you can obviously tell that this is this saves a lot of time. Let me move on, because that's not the only distance we are worried about. Another distance which we are worried about is what we call the interbolt distances. So for example, if I were to just open this up for you a bit. Now, you're familiar that the standards define what kind of distances we need to have. So it says, in order to achieve the best bearing strength values, codes recommend minimum distances between bolts and edges. And these are typically recommended as multiples of the hole diameter. So for example, the code would say that if you're using an M20 bolt, and this is the direction of the load, then the distance in the direction of the load should be, if you keep it around 3 times the diameter, so let's say it's M20, so if you make it 60, then you will get the maximum bearing strength from the plate for the plate failure. If it's less than that, if you're forced to do it less than that, then of course you will need to do a calculation. But it's good practice to have your distances as 3D between bolts. And similarly, at the edge, in the direction of the bolt, it's 2D, and in the direction perpendicular to the bolt, to the load, it's 1.5D. Now, once again, this comes down to entering a lot of numbers. That's what we are trying to avoid. That's what we don't want. Now, let me see where I can do an example for this. Yes, let's go back to the model. Now, if I go in there, for example, and first thing let's talk about over here as well. Let's go back to the smaller angle, for example, over here. Let's do a 60 by 6. It's a smaller angle. Now, what has it done regarding the interbolt distances over here? If I go to my file menu, there is something called project preferences. And inside project preferences, we have a tab called the bolts tab. And in the bolts tab, we define for all diameters. So for example, for M16, I can define that 3D distance. So I'm basically telling it in advance that wherever you come across an M16 bolt, use 48 millimeters for the in the direction of the load. I can change this to 50 if I want. I don't need to be exactly 3D. I can put a round number. For example, in the M20 bolt, the 3D distance I've taken over here is 60. The 2D distance, which is from the edge of the plate, is 40. And the 1.5D distance, which is perpendicular to the edge, which we just showed you, is 30. And now suddenly, after having set up this project preferences file for each bolt diameter, all my macros are automatically taking the interbolt distances from here. So if I were to measure the distance between, for example, this bolt and this bolt, it's 48 millimeters. Why is that? Because these are M16 bolts, and automatically it knows that for the M16 bolts in the direction of the load, I need to do that. Similarly, if I were to measure this distance from here to the edge, it'll be 2D. And similarly, from here to here, it'll be 2D once again, without me actually having to go inside the macro and go to those distances, for example, over here, and then enter those distances over here. Once again, the whole idea is that we don't want to enter anything. We just want to go click, click. That's the whole idea. If I were to show you some examples from beams, for example, over here. So let's choose some beam connections, for example. Let's choose, for example, let's do a stiffen end plate connection, for example. It is the bolt size over here is 20 millimeters. So what should be the edge distance from this to the edge of the plate in this direction? If it's 20, then it should be about 1.5 of that. So it should be about 30. So let me just go and measure that. Let me go from here to the edge. It'll be in the X direction, as you can see on the screen. In the X direction, it's minus 30, which is exactly what I want. So I didn't have to go inside, open my things and enter these numbers over here. It wasn't required. It automatically filled them up for me. If I were to use another macro, or if I were to, for example, choose a different bolt diameter. So I could go in and I could change the bolt diameter from 20 to 24, for example. and just say okay. And if I do that, automatically, if you this is now an M24 bolt diameter. If I were to measure the distance, this one gets to 36 now because it's 1.5D, but I haven't changed anything in the macro. I'm just changing the bolt diameter. And the edge distances are automatically changing for me. I can do that with another macro as well. Over here, once again, this one is M20, and I automatically see that if I like go in like that, I can measure from here to here, and it's 30. This is just the way I want it to be. So as you can tell, the whole idea of one-click connect is to automatically enter these, let me go back in here, these 2D, 3D, and 1.5D distances automatically from your project preferences, and also the gauge lines, if it's on the flange or if it's on an angle, the gauge lines over here, which I haven't shown here, but I can show them in this diagram, for example, are automatically taken from those files in the background. Now, this is really convenient because what it helps you, if you think about it, you're constantly using macros and you're constantly entering these numbers. And most of the time you spend in modeling is basically spent entering these numbers. And I haven't explained all of it because today's webinar is about a certain part of that. I haven't explained everything, but the idea you can get very simply. I haven't explained, for example, how the number of bolts is calculated automatically and how the bolt diameter is calculated automatically, or how the plate thickness is calculated automatically. But the whole idea is that all these things are done automatically in the background, and all you're doing basically is going click, 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 which is basically increases your modeling speed tremendously. Now, bolted gusset, I wanted to give a few more hints today regarding the bolted gusset macro. After giving normally the bolted gusset macro is typically assumed to work with angles and or some profiles, but nobody really assumes that it also works with plates. So I've created a little example over here. So this is kind of like a built-up column. Let me clear the clutter up a bit. So here's a built-up column, and there's a plate over here, and there's some angles over there. You can also use this bolted gusset macro over here. People usually think, and they don't realize, they think that the main member needs to be a section. But in COMOSYS, the main member can also be a plate. So I can select this plate and I can connect these two to that plate very easily. And what this tells us that in COMOSYS, these macros can also work with plates as their main member. Now I want to show you a few examples which are also kind of hidden in the sense that people think that the bolted gusset macro, the assumption is that the bolted gusset macro will typically work for angles or, basically for angles. But there are many other cases for which we can use this macro. So let me start off with eye sections. So here is an example of an eye section. Now, when would you have eye sections as braces? When the loads are very large. And when you have large loads, you can't work with angles or small channels or stuff like that. You need eye sections, but the eye sections have their unique connection. It's not like the typical gusset plate connection. So, for example, here's a beam, and there are two eye profiles coming in as vertical braces. If I go to my bolted gusset connection and just select the beam and select this one and right click, I can immediately see that the same macro which worked for the angles, this is one thing you will note in COMOSYS in a lot of places, that we don't have too many icons. You don't have separate icons for everything, like hundreds and hundreds of icons. What we want is compactness. So we have this idea of one icon does a lot of things. So this one, for example, now it's an I-beam, and it's coming with this rotation. The flange is like this. And as you can see, it has immediately, so let me just select this assembly over here and show that only. You can see that this has created this assembly very quickly, and it has connected those I-beams as braces. Now, the same I-beams could have been rotated as well. this is a different orientation, but this one over here, the I-beams are rotated as they come into the incoming the main member. If I were to connect this one and this one, a different kind of connection is created. Now, if I were to select the column and say select assembly and show only, you can see that it is a very it's different from the other connection. Once again, this is all part of the bolted gusset, the gusset plate macros over here. You can use them for all these cases. Let me turn everything back on again. So let's see. We have the bolted gusset with flange side and the bolted gusset with the web side. I can show you some other examples of pipes and so, for example, let's see what we have over here. So this one is a pipe, for example. Once again, I go to the same bolted gusset connection and I select this one and this one and this one and right click. And we have a bolted gusset connection over here with pipes. Now, this is with an end plate, and there are other types of connections sometimes used in which the different connection is that you don't use an end plate because this can create a different kind of stress, but you actually insert this plate all the way inside. So, for example, if I were to disconnect one of them just to make it easier to understand, I could go inside my gusset plate macro, and what I could do is I could go this is also one of the hidden things which people sometimes miss, that it has extra settings over here. If I press this and open this dialog box, I can make some extra settings. For example, one thing I can do is I can put the plates on both sides, or I can put them on one side. Or I can actually do, instead of the end plate connection, I can do another type of connection which goes like that, which means that I don't have the end plate now as the main load carrying thing, but this plate is actually being pulled inside the brace, and it's being welded over here to the sides. Or I can do a completely welded one over here as well. So many options, which are all inside the same macro. They also work, for example, with boxes. If I go to the box profile, I can go once again over here, and right click, for example, and I have the same options which I just showed you for the pipe. Once again for the box section as well. Let me just open that. Yeah. So I come back to my secondaries. This is where they are. You can just need to press this one and open this one over here. And once again, you can do an end plate one, or you can just insert that plate inside the section. What that means is that this main part will be cut. If I were to just show this one only, it's basically cut and the plate is inserted inside it, and it's welded over here. And you have this very nice connection, because in this case you avoid the end plate, which can be with certain people, some people might not like. So it can be single plate, it can be double plate, it can be with the end plate, it can be all inserted all the way inside, it can be welded as well. The same works for pipes. One thing I want to show you is, which is interesting, which is once again one of the hidden features. So this situation is quite common, where you have a face-to-face angle. Face-to-face angle which is opened up. Now, one thing you will note in COMOSYS is that the twin profiles are single ID, so you can move them together. So I could say Control Q and the whole thing rotates. Control Q again, and the whole thing comes back like that. So the whole thing is together, and I can change their distances directly from here. The distances between the two angles directly from there. Now, in a situation like this, once again, I could go to my gusset plate macro and just go like that, and this one, and right click, and immediately I have a double gusset connection. So one gusset on this side and one gusset on that side, and it's all connected by using this single macro, because this is a single profile, and it also immediately recognizes that it's connecting to the flange because it's been opened up. The same situation can exist over here as well. For example, here we don't have face-to-face angles, but we have back-to-back channels opened up. Normally you would have them with batten plates as well. I'm just for the sake of illustration. If I were to go to my bolted gusset macro, and just select the column and the bolted gusset, once again, we see that the double gusset connection has been created. This is very useful. Normally, you have to do them separately, and it's automatically realizing where it is, which part it needs to connect to. It's giving you all the options which you want. So this is really, really useful. People don't use the bolted gusset macro to its full potential. And this was one of the reasons I wanted to mention this in this webinar. So what did we talk about? We talked about the gauge lines. We talked about the edge distances, all coming from project preferences, and the flange angle distances, angle gauge distances file, and the flange bolting text, that file. And then we talked about the project preferences file, which gave you the interbolt distances. And then we talked about, so this is, for example, another profile. This is a twin profile. It's you can select it as one member. And all you need to do is just go into your bolted gusset and go click like that, and you can have your connection. Now, one good thing about these things is that you can actually double click on these on the main member. And if you go to your detailing definitions, there's something called axial capacity ratio. 0 basically means a default value. But if I were to, for example, say 1, it would mean make it work at the full axial capacity of this member. Just doing that would automatically change the number of bolts and the plate size and the welds and everything, because it's going to do a back of the envelope kind of preliminary design for you. Let's let you know what kind of how many bolts you would typically need. All these are connected to the material constants file, which I don't have time to talk about right now, but just letting you know that by changing this number over here, let's call it 0.6, for example, that means make it work at 60% of the capacity of this member. And when you do that, then the connection automatically modifies itself. I think that's, we've basically done about 30 minutes. I don't want to take too much of your time, so I'm going to stop sharing.